Hey everyone, welcome to the Latent Space Podcast. This is Alessio, founder of Kernel Labs, and we have back in the studio Quentin Anthony from Zyphra and EleutherAI. Welcome back.
Thanks for having me back, Alessio. It's great to be back. Do you want me to introduce myself?
Yeah, give people an update. I think last time you only had Eleuther and you were still at Ohio State. So
yes. So now I am head of model training at Zyphra. So we're a startup building foundation models, especially with a focus like on the edge. And then I'm still head of HPC and sort of an advisor at EleutherAI.
Nice. So we reached out because you were in the maybe controversial study about wood meter and like engineering efficiency. And obviously you've been doing a lot of great work at Zyphra on open source, but maybe there hasn't been a public update in a while. So it would be nice to get the latest from you. We want to talk about AMD. I think that's another interesting topic. We just had Chris Lanner. But let's start there, maybe. Let's start with like your actual work, and then we'll kind of dive into the more side quests that you've been working on. So what's the latest on Zyphra and like what you're working on? I think some people might be familiar with some of the like Mamba adjacent models that you released in the past, but how should people think about what you work on and the current research direction you're in?
Sure. So Zyphra is a sort of full stack model company. So we get our own data, we make our own models, we do everything in-house. The focus is on pre-training from scratch foundation models that are currently focused on edge deployment, so on device, that sort of thing. But we also are starting to dive more and more into like cloud deployments. We recently moved all of our training cluster over to AMD. So we're really going all in on the AMD ecosystem. We think they're really compelling training clusters and it reduces our bottom line. And I would say in terms of model training, stay tuned soon. But the more recent models, we did a lot of like state space hybrids. We were one of the first to that, sort of like a Jamba style. We released Zamba 2, which was a hybrid between transformers and Mamba 2 blocks. And we were able to beat like Llama 3 8B, for example, with a 7B model.
When did you decide to go to AMD? I would say that's maybe something that everybody's always rooting for AMD to work, yeah. And then the software is not that great and whatnot. Mm-hmm. What was the origin story of moving on to AMD?
So when I was working on PhD more heavily, I was working on Frontier, which is a supercomputer at Oak Ridge National Lab that's totally based on MI300X AMD GPUs. So out of necessity, I had to make AMD GPUs work. So I ported flash attention over to those. Very painful. We trained a 7B model there on purely on like scientific papers to try and create like chemistry models. So kind of I figured out, you can make these work. And the hardware for MI300X wasn't quite there yet. Then moving to Zyphra, there were a lot of companies, smaller clouds like TensorWave, for example, and then larger players like Azure and whatnot were starting to move more to AMD, specifically on inference serving, and they had a lot of time that they would give to developers to sort of see the ecosystem a little bit. So we released a blog at Zyphra on porting flash attention 2 over to MI300X, just to sort of play out, can we move our own stack over, given my prior experience. So I lead the team working on kernels there. We found that it's great. For flash attention 2 specifically, we were able to beat H100. We also found that like the less time you spend in like dense compute, like the less time you spend in tensor cores specifically, or less time you spend in lower bit width precisions like FP or so, and the more time you spend in parallelism or moving to and from HBM, MI300X actually has quite a bit better hardware metrics on those. They have 192 gigabytes of VRAM, so you have to spend a lot less time working on parallelism strategies and trying to overlap all that communication time. If you're taking any sort of data from HBM, you have much higher memory bandwidth, for example. So if you're doing like a non-FP8 dense transformer, maybe even like an MOE or something like that, then you're able to beat H100 quite handily. So we found it compelling and we moved over. Go ahead. Yeah.
There's kind of like Sarah Hooker's hardware lottery thing, which is like, hey, the models that work because they work well with the hardware that we have.
Yeah.
Do you feel like all the work you've done is something that in a non-humble way you need somebody as cracked as you and your team to do? Or do you feel like people are maybe a little complacent with like, they just complain about AMD and it's like, well, you can just work and fix it?
Some of it is groupthink, but I think a lot of it is deserved in that like it took a long time for hardware to catch up. Like I would say MI250X was not on the same level of A100. You had like 2 separate GCDs on each GPU. So you basically had to split across, you had a 3-level parallelism scheme instead of a 2-level on NVIDIA, where you just had within the node and across nodes. Now you have within the GPU, across GPUs, and across nodes on AMD. With MI300X, the hardware caught up. And then from there, software took a while to catch up. So when MI300X first dropped, if you run like an MLP gem or something, you would get like 400 T-flops. Now that number is, more like 600, 607 650 or so, just in like the gem backends themselves. A lot of documentation has been caught up. So they caught up on hardware. Now they've caught up on software. Not a lot of people have sort of discovered that they've caught up on software, and we're kind of capitalizing on that. So it's not just, if you're good enough, you can do it. If you evaluate everything evenly, you find these sort of diamonds in the rough, I guess.
What's the state of the AMD savior? So you have TinyGrad, you have Mojo and Modular. You basically have this kind of like these groups trying to make better software to make AMD just the same as NVIDIA. Are those interesting directions? Have you gotten value out of it, or did you have to re-implement a lot of it from scratch?
Let's see. So I am not actively using things like Mojo. I'm actually, you can get pretty far by using the ROCm backend on a lot of higher level software like Torch, for example. And then you just write all of your own kernels. And a lot of the time when you're training models, especially, is spent in those core kernels themselves. Like the transformer math work led to trying to really profile how much time do you spend within a training iteration. Most of that is in attention and MLPs, right? So if you have good kernels for attention, MLPs, and norms and so on, then it doesn't much matter what the front end to send tensors to and from those kernels is. Now, on things like Triton, for example, that you are beholden to the Triton compiler and who wrote the Triton compiler for that specific hardware. So when I want to make an optimization to say flash attention, I don't go from the top down. I think, what Triton kernel do I write, and then go to the hardware. Instead, I think from the bottom up. The hardware of MI300X has these properties, and I want my algorithm to pull these properties out so I get the full benefit of the hardware. So if I have some optimization that's hardware specific, I both have to understand the optimization and I have to change the Triton compiler to work for this case. So it adds another layer of complexity. So I find myself more and more working just purely in ROCm to write the core kernels, and then I just expose it with some Torch interface, and that gets me pretty far.
Interesting. Yeah, it does feel like there's a lot of opportunity there. I think when DeepSeek R1 came out, everybody was going crazy about, they went so deep in the actual GPU code to improve things. And I'm like, why are you not doing it? If you're spending all that money training.
Yes.
Do you think it's something that it's worth open sourcing? I guess that's one question. Is especially with Eleuther being such a, you have maybe a duality of roles. Yeah. Do you feel like an open source group should kind of take this on? Or do you feel like because the kernels can be so tailored to the type of workload that you're doing that everybody should just do their own work on it?
Open source should definitely take a look. And my suggestion there is you need to drive adoption. So for example, Mojo, I see it as someone who is extremely talented, like Latner is extremely talented. He found an actual problem and he had the agency to go out and do something about it. But until you sort of get a critical mass, a sort of threshold of people behind you, then you have to keep dumping a lot of talented people and money to keep up with the rest of the field kind of thing. Maybe TinyGrad is another example of this, right? So it's great, but do I really want to slot my entire training stack to them and go all in? As an organization, hard sort of decision to make. I think open source's job here is to get a foot in the door, make some small models, show that it's actually viable. AMD and themselves have released some models around the 1B pre-training that they pre-trained from scratch. And open source just needs to keep picking that up and start small and get larger and larger instead of trying to replace the whole stack.
Yeah. Do you think it's worth for people to spend a lot of time on the current AMD generation? Because I think the other question is I'm going to do all this work versus I just write CUDA code that then when the BG200 comes online for my cluster, I'll just switch it over right away. Do you feel like there's certain maybe model sizes at which, if you're training a 7B model, like the Zamba one, you shouldn't even worry about the next generation of NVIDIA because the workload is somewhat confined now?
In terms of, I am not fortunate enough to have the timescales to wait for the next GPU. I don't think I've ever been in that situation. So it's always what do I have? What is the training hardware that I can actually buy today? And then once I have that, how do I pull as much as I can out of that hardware? Unfortunately, a lot of kernels that are as optimal as possible, like Flash Attention, for example. Flash Attention 1 is sort of a V100, A100 sort of scheme, and then Flash Attention 2 is more to A100. Flash Attention 3 goes even further down this line of being co-designed on H100. And these, you can port Flash Attention 2 over to MI300X because they sort of follow the same hardware steps that NVIDIA did. But a lot of kernels are tied to hardware. TinyGrad is also in the same sort of setup where they're trying to train on consumer hardware. So necessarily a lot of their attention kernels, for example, are tied to consumer hardware. So I don't think I personally ever look past the current generation. And when the next generation comes around, then I take and I say, okay, back to square one. What sort of things can I port? And I port over again core hardware designs that don't change too much, but I almost always have to do due diligence and to tear out major portions of my kernel to fit the new hardware.
Right. Yeah. Yeah. Can you give people a quick overview of like what are the core pieces when you're writing kernel? So a lot of our audience is like AI engineers, not necessarily AI researchers. And I think obviously people understand CUDA is like, a big lock-in, then there's like cutless. What are like really the things that in your mind are like, okay, this is like a huge advantage versus like, this is like part of the offering, but like I can replicate that somewhat easily on AMD or whatever else.
The ecosystems within NVIDIA and AMD are actually quite similar. So from going from bottom up, you have PTX, so basically GPU assembly on NVIDIA world, and AMD world, that's AMD GCN. This is only if I need absolute control over the hardware, and I've tried Triton, doesn't work. I've tried CUDA, it's not giving me the control. I'm like, oh, great. So then I have to go to PTX or whatever. That's kind of sort of a last resort, but I can make the hardware do whatever I want when I go there. On top of that would be sort of CUDA and HIP or ROCm on the AMD side. This is sort of the happy medium. It's lower level than most people work in, but it still does almost everything I need to do. But if I want to, a lot of deep learning ops kind of rhyme. So a lot of deep learning ops require GEMS, for example, which is generalized matrix ops. I probably don't want to write a GEM kernel from scratch. Like NVIDIA people have worked on that for a long time. So I would use something like cuDNN or something like that with some gem backend. There's a lot of like building blocks that people have made. So I don't want to reinvent the wheel when I'm writing like a flash attention kernel. I don't want to rewrite each matrix multiplication. So I try and plug those in as possible. A lot of those are written in CUDA or there are sometimes in closed source libs. On top of that, there are, I would say, like these template libraries that are getting more and more popular. So like on the NVIDIA side, it's like, Cutlass or Qt, where you can kind of like focus more. I have these Lego blocks and I want to focus on how to link them together, how to fuse kernels together. So that would be the NVIDIA side. And then on the AMD side, they have this composable kernel library that does something very similar. They say here are your gems, here are a few other specific ops. You just focus on making like a custom epilogue. So what happens at the very end of your kernel? How do you fuse two of them together? That kind of thing. And then on top of that, you have these maybe these are maybe not on top in terms of like a software stack. There may be like a vertical line throughout. Would you be like Triton or Mojo, which is kind of, or even Torch Compile on top of that, which is kind of saying we try to handle all of the backend stuff for you. We compile down to AMD GCN and PTX. You just write the basic subroutines, and hopefully they map to things that the Triton compiler or anything else understand and are common ops.
Yeah.
So
that's great. How do you think coding agents help with that? Like, have you found that it's easy to leverage that? And I guess the other question is like, how verifiable are these kernels? So if I've read a kernel, how do I measure the quality of it, the performance? Like, is that easy to do? Or
so I find agents and models today like really good at the higher level stuff. So if I'm trying to write some like fusion of two kernels, or if I'm trying to write something in Triton that's very high level, models are great. And as good as they can be when I'm talking about GPU kernels, right? Limited success still. And if I want to like write templates or skeletons or like initial setup, I give it a design. I say, just kind of make me the broad setup and let me focus on the heavy stuff. Saves me time in that for sure. Getting below Triton or level or anything else down to like CUDA or below, there's orders of magnitude less public good kernels at that level. And I think that really shows in models' capabilities. So when I try and get a model to do something in CUDA or PTX or something, if it's not dead basic, it's bad really fast.
Right.
And I think everyone can kind of speak to this. Like when I use a model, it's harder to debug because I don't understand the code. And when I'm working in systems and low-level code, the debugging part is much harder than code that I can more deeply understand. It's hard for me to map out how a GPU kernel is working because it's very parallel. And that is worsened by far. So not only are models kind of bad at generating kernels because they have very little public training data on them. TreeDAO is like one example of making very public kernels, but how many more do exist?
Right.
There's a lot of Triton ones, not many CUDA ones. And not only that, it's harder to find the issues themselves in those generated kernels because it's hard for me to map out everything that's going on in my head.
Yeah. With a kernel data set, how valuable would that be? If somebody was like, hey, here are like 10,000 amazing kernels that you can put in context or like fine tune a model with or whatnot.
It would be great, but it's not a silver bullet because kernels are also hard to validate. It's hard to have like an eval on kernels. Every time that someone releases like, oh, we created a new eval that measures kernels and we trained a model that generates kernels so that no one has to learn CUDA again. There's always a few smoking guns in there where there are kernels that are impossible basically, because the model has found some sort of way to, game the system. It's trying to find anything that checks your metric. Do you if you just check some stupid example, if you're just checking latency, then the model will compute something really fast but wrong, or something, right? And but in subtle ways that's hard for you to find. It's hard to get like a very sealed, closed loop eval that measures whether models are good at writing kernels, whether they generate them well. That also makes synthetic data hard to generate kernels. And then it's hard to get the training data in the first place. So it's like not unsolvable, but it's obvious to me why they're not any better than they are now.
Yeah, what's the kernel writer workflow? Personally, I've always built applications, right? So I know what that flow looks like. Yeah. So you got to write a kernel. How do you start? How do you sit down? How do you work? How do you test it?
Okay, well, kernel is a last resort. So first I go, another kernel, oh my God. And I try and find some way to go around it. But if the kernel is necessary, it kind of depends on what I'm doing. So if I'm doing a lot of problems can map to this sticking Lego blocks together. I have some sort of new model architecture that changes attention, and I can just fuse an existing flash attention kernel onto some epilogue. And I try and do that. And I just kind of keep repeating that workflow and going lower and lower, seeing, okay, how much lower to the hardware do I need to go to get this thing to do what I want? And then, kind of reach bedrock, right? If Triton doesn't do what I want, then I need to go a level lower. If I'm doing...
And when you say doing what I want, what does that mean usually? Is it part of it latency? Is it computer fit? What are the dimensions that make a kernel good? Implementing
my exact design. So I come up with a design. I say, I want this tensor materialized in registers or something. And if I just tell Triton, if I do some Triton instruction, I don't have total control over where that tensor is instantiated. Maybe Triton decides keep it on HBM and then page it into registers every time or onto tensor cores whenever I need it. And that's not what I want. So I have to watch where that tensor goes. And if it's not doing what I want, I either need to change the Triton compiler, or I need to go a level deeper and say, okay, I want this tensor where I want it. Otherwise, I'm wasting time going to HBM or back. So that's why implementation of my design, which I've decided a priori on a whiteboard.
I think for a lot of people, they hear about kernels, but then it's in reality, what are these kernels?
Yeah. I will also say that if it doesn't fall into this Lego building brick scheme and I'm really doing something new, then you got to go down deep to the hardware and say, this is what I want the hardware to do, again, on a whiteboard as the first step. And then try and just, what is the highest level tool that will actually do what I need it to do?
Yeah. How often does that happen? I feel maybe 3-4 years ago, it's very often. Today, what is the set of problems that you're net new trying to solve?
Entirely depends on how much model architecture you're changing. So if your business design is, I want to train models on some new type of legal data or something, I don't need to change attention that much. Maybe I make it a little more accurate for longer context or something. But if I'm not changing the model architecture, I don't need to write a kernel. If I'm not using some new GPU hardware, then I don't need to write a kernel. But if you're trying to make new model architectures like I am that are efficient across, a lot of edge deployments, if we're trying to compete with organizations that are pre-training with much more compute and manpower budgets than I do, then I have to sort of take nothing for granted and squeeze out as much juice as I can out of every parameter and every T-flop that I have access to.
Have you worked with any of the GPU alternative hardware, like a Grok, Cerebras? Any thoughts on pros and cons? What are maybe things that are still not doable there?
Not a whole lot. They fit a niche that I'm not into right now, which is inference economics that are non-standard. So Cerebras is really good for super low latencies, and I'm not really looking at low latency inference right now. My main concern is training performance, and I'm my own client because I'm the one paying the money for training. When we produce models that everyone loves, then I will jump into the inference side if I care about that. But right now, no. Yeah. I won't speak much to that.
And because of their structure with mostly SRAM and whatnot, it's not even a thought to use them for training, obviously.
It's interesting. I'm an interested observer. I think examples like Cerebras especially, they kind of overlook a lot of quality. They overlook that the hardware has uses beyond what they see immediately. It doesn't necessarily have to be, they compare it to what NVIDIA does well and they say, okay, well, it doesn't do that well, so what's the point? But if they can find a niche that's economically viable, then absolutely, they have value.
And what about, now there's a lot of talk about, maybe if you train a model, you can make an ASIC to then run inference on the model. Is that something that when you train models, you think about is the target hardware for inference, or do you feel you already have so much work to do before that?
That's top of my mind. So is inference performance. So we train models that are inference efficient. So I did a paper with Eleuther a while back called The Case for Co-Design with Model Hardware. And we find, like, for example, if you, choose like a hidden dimension that has many powers of 2 in it, then it's much easier for a GPU to split that up across a lot of tensor cores. So we see, okay, these are all the inference hardwares that we intend to deploy on. These are the sizes that they're most amenable to. These are the kernels that they would be using. And then how can we choose like the model sizes so that they are most amenable to as many of those as possible? So like absolutely I do what I can. But if in 3 years I'm creating a model, then if in 3 years I'm trying to infer that model on some new hardware, then yeah, I'm kind of screwed. Probably need to train something new.
Yeah. What's I guess like the timeline for like an ASIC or something that would make you feel interested in doing that? So I think the most criticism today is like, well, to like actually tape out an ASIC, it might take me like 18 months. And like by the time that comes out, the model is already obsolete. If it took 6 months, then what would be the cost in your mind that would be worth? I don't know if you ever thought about it in this terms, but it's like if you could spend $100 million to build a custom ASIC that comes out in 6 months for your specific architecture, what would be the math there? Would that be a good number? Like how cheap would it need to be? Maybe it's never possible to do it in the right price and timing, but like I'm curious, like today, what would be the number for you if you have one?
If I was sort of in-house, maybe XAI is a good example of this, or Microsoft is another one where they kind of know the model architecture a priori, then they absolutely should make an ASIC that is custom designed for that model architecture that they're currently training, and then try and line it up so that they run inference on the ASIC at the end so that they keep everything in-house. They don't have to spend a bunch of money on different hardware, and that ASIC is probably going to be custom made for that model anyway. Like model generations are getting a bit longer and longer, so it's good to have an ASIC that lasts the whole thing. In terms of exact timelines, like I'm not knowledgeable enough to tell you the exact numbers that I would guess. If that changed in the future, then I would come back and tell you.
Yeah. Nice. Yeah, I think that's a good. And I mean, again, I don't know how much you spend looking at this, but how tied to like the actual model implementation would that need to be? Like, is there like a middle ground between a GPU and an ASIC that is like the weights burn into the chip, where you can be, okay, this is like the Zamba ASIC, and like, Zamba 1, Zamba 2, Zamba 3, they'll have some differences, but like most of it will work the same and reap the same benefits.
This spectrum already exists, I would say. So I would say like on the extreme, more ASIC side, you have like an etched kind of company or Grok or something. So like Grok is very inflexible hardware, so that you kind of, if you want to do like a Mamba SSM on it, you're going to have a really hard time, because instead of having like a low level CUDA compiler, like everything is like designed in at the hardware level, right? And then Cerebras is kind of more in the middle, more maybe towards the CUDA side, and then GPUs are, as fairly general purpose. So kind of a spectrum already exists today, but I definitely think things are moving towards you design a model, it's sized the way that fits well on hardware that you can design. You immediately start creating an inference hardware that is custom made to fit the sizes of your model. And then you can also sort of, this is kind of an anti-open source situation, but you could design your model to only run well on your inference hardware if you size it in a weird way that doesn't perform well on anyone else's. I kind of see things moving that way, but we'll see what happens.
What about, I mean, maybe one way to think about it is like Apple, right? I think Apple has their own stack that like they say secure enclave that not everybody got access to. Maybe they haven't done as much on actually building good models to put on the phone. I know at Zyphra, you had spent some time thinking about on-device inference, especially for like smaller devices. Do you feel this still like an interesting direction? Is like, do you feel like we had Greg Brockman on the pod and we talked about the GPT-5 to GPT OSS handoff, for example, that could happen where like you have OSS on the device and then it hands off to GPT-5 for more compute intensive tasks. How do you think about that? And then Zyphra's strategy too of like what size model are interesting to build and things like that?
Like I was saying, we sort of look at all the edge deployment hardware that we want to deploy our model on, and then we just size a model appropriately towards that. And that often looks like a spectrum of models. So like the Zamba 2 suite, we had like a 1.2B and then a 2.7B and then a 7B. And those were for like extremely resource constrained edge deployments, and then maybe like laptops for the 2.7B, and then I don't know, like desktops or cloud serving for the 7B. And I kind of see people doing that same thing, sort of designing a spectrum of models for the spectrum of compute, and then those smaller models kick back to the larger models when they can't answer a question. So you kind of have like a model merge GPT-5 sort of mode where you have an inference efficient model on your phone, and this is, oh, I can't answer this question. You're asking me for a reasoning trace in math. It kicks back to GPT-5 in the cloud and gives you an answer. I kind of see things moving that way. So you only spend the inference cost on what you need.
Do you see the intermediate of kind of like the, tiny box, or like K16Z has built this like inference thing where it's like a box that you have at home, which is like maybe like 4 GPUs, and it's like in between the two? Or do you feel like once you're ending off device, might as well just go to the cloud most of the time? So
those specific kinds of boxes, not for people at home, I don't think, except for some extreme hobbyists. I see them more at like organizations maybe. So if you are, I don't know, Chase Bank or something like that, and you want to spend less inference money to a provider like Databricks or something, then maybe you have a few of those boxes in your data center, and all of your like custom code generation on the Chase Bank software stack goes to those first, and then kicks back to some model in the cloud if it can't answer it. So I do see people like organizations trying to silo on private local models that run on private local data centers or small like mini clusters, but things will always need, well, I won't say things always need to be kicked back. We'll see, but definitely not consumer, I don't think, for those.
Yeah. Well, I think the humanoid robot thing will be maybe the first stress test of that, like if you're putting these things into your house, are they always going to be connected externally? Yeah. Are you going to have, they bring you the robot in like a rack to put in,
or cars
in your totally. Yeah. I think it's interesting because cars have like almost like no weight requirement in a way, which is like, whatever the car weighs, it weighs, versus if the robot, I forgot who said it. It was like, if the robot falls on your grandma, it's like really bad as if it's like really heavy or not. So I think Edge has been interesting. I've tried the GPT-OSS model on the Edge too. I would say the time to first token on like the local models is always like a little slow if you don't have them in memory. Yeah, which is almost like most of the queries that I would want to ask the local model are kind of like one-off, quick things. So I haven't quite found the use case for them, but I don't know. I'm curious what you've seen. What are like maybe some of the more interesting like edge deployments that you've seen? Well, first, when you say GPT-OSS on an edge deployment, what edge are you deploying it on? Oh, on my MacBook. Okay. I just use the 20B on True Llama. This is like a 36 gig RAM, so it's like somewhat fast, but obviously the loading into memory is kind of slow. For a while, I would deploy on my laptop like coding models, because sometimes I'm on a plane, or sometimes I want to spend less money on my whatever deploy or my like API, but it kind of lags in quality so far, and I haven't had a specific enough problem to warrant like sometimes an open source model you can just fine tune on something you really care about and deploy it, and that I haven't really had time to keep up with and run it myself. I'm not a good example of the people running these sort of edge deployments. Instead, I kind of want the most quality, and I'm willing to pay for it because it's what's keeping me from training the next model. So I tend to more compare Claude with ChatGPT or someone, and find which one does the best for my problem. And I pretty rarely use local models unless I'm just asking a one-off question and it's faster to do over Google. Yeah. Do people come to you and they're like, hey, this is like my small model use case. Can you guys make it better for this specific thing? What are like those use cases? Can't really speak to those. Okay. Yeah. That makes sense. I don't know how much you want to talk about what you have coming next at Zyphra. Like, do you talk about, you're somewhat secretive as a company, I would say. I think if you go on your Twitter, there's like 5 tweets in the last 5 months, something like that. Do you have a roadmap that you usually share with like the research engineering community, or are you very, once the model is out, you'll know about it? We tend to go towards the latter scheme just because there's so much noise. And if we keep saying, oh, we're about to release something big, it kind of takes away from the announcement, I feel. We tend to wait until we have something to say. And we do have things to say. We're just kind of like, we kind of want to ambush, right? It also gives your competition a little bit more time to pivot. And we're kind of trying to, go towards the next thing for model architectures and stuff. So that time is moot. I would say expect more models that are easier for more people to adopt. I would expect to see higher quality models, and I would continue to expect models that sort of push the envelope. And when I say push, that's a silly thing to say, push the envelope, but we're not afraid to take big risks for model architectures. So we're not going to train something unless it does exactly what we need it to do.
and we won't just sort of take something off the shelf unless we can find something better. That doesn't mean we create something better for the sake of it. We don't want to do something new, but it tends to be there's a lot of low-hanging fruit for us to find.
Yeah. Nice. So you were a part of the Meter software engineering productivity with AI. Can you just run people through what that was like? So how did they onboard you? What were they trying to measure? How were you measure? The backstory on the setup.
Sure. Lead development on a model training framework called GPT-NEO-X, which is like a model, Megatron deep speed style framework for pre-training models on HPC systems. It's this is sort of work I do outside of my core Zyphra work, and there's a lot of adoption. So this is kind of the standard. A lot of academic labs, there's a lot of usage. A lot of people who need pre-training kind of go to this framework. And Meter was looking for prominent open source projects to watch you do your work in the wild and see how well does AI speed you up, and try and be as low overhead and affect the process as little as possible. So they came to me and said, hey, would you like us to just kind of watch how you use models and take very detailed logs about how things sped you up, where they sped you up, that kind of thing. And I'm like, yeah, sure, absolutely. I already use AI sometimes in my workflow. Totally fine. What I would basically do is I would create a bunch of GitHub issues that were already on my roadmap. And then they would sort of do a lottery of use AI in this one, don't use AI in that one to speed you up. And then sort of write down detail, like how much time do you expect to spend on those tasks? How much would AI speed you up on those tasks? How much time did it actually take you? And then write very detailed logs of like what you actually did. And so I did that. And so that's where they get the estimated speed ups. So I put out all the tasks, and then how long I expect to spend on those tasks with and without AI. So then I just, for several months, I just did my regular work on the time that I could have on those little issues, and then put the extra time it took me. And the AI sped me up a bit, but only in specific cases and only when taking a lot of sort of digital hygiene practices. But what else that's the setup.
Great. Do you feel like the tasks that you were measured on versus the one that you were not measured on align with like where the AI is good? Because I think in my mind, that's like the biggest thing is like some tasks I know the AI is going to be good.
Yeah.
Some tasks I know is probably not going to be good, so I'm not going to use it. It feels like in this process, do you feel like it was like the right fit, AI, not AI? Or like, do you feel like the results are maybe not always, descriptive of the actual ability because maybe it would just assign the wrong task?
Mm-hmm. Well, I was measured on all tasks, but that's kind of where the expected time with and without AI comes into, because I would give my expected time for both. And there were some tasks where like I knew the AI would one shot, like writing documentation.
Right. Yeah,
and I was like, okay, this is going to take me 10 minutes if it's AI, or not even 1 minute if it's on AI, it'll be one shot. But it'll probably take me like an hour. And then when the lottery came up as you can't use AI, and I was like, oh, great, okay. And then sure enough, like it took me like an hour kind of thing. But it was totally random. So can you clarify the question a little bit?
Yeah, well, no, I think that's the thing. It's like, this is a good example of like, does that mean that the AI got like a negative scoring in that case? Because you could have used AI and taken 1 minute instead of spending 1 hour. And then you could have used that 1 hour to do something else. And then eventually means you were sped up. I think that's the question that people had is like, is this a task by task or is it an overall workflow thing? And it sounds like it's more about the task. And sometimes you could have been sped up overall by not doing a task, but the lottery told you to not use AI.
It's task per task.
Okay.
And then if I can't use AI, I don't use AI. But I would write in my notes that these are the parts that I thought could be sped up by AI. A lot of it is also just reading other documentation, like with deep research or something. I need to know what documentation to link to. I have to do a bunch of Google searches. Models speed me up on that too, not just raw code generation.
Yeah. Interesting. You had this nice Twitter thread about old people in Vegas clicking slot machines.
That's how I feel.
Well, I guess let's run us through your setup. So what do you use for agentic coding? Do you use just Cursor? Do you use Cloud Code and whatnot? Yeah, and then we can kind of dive into more like, if you use agents.md, what do you write in it and things like that?
So I personally don't really use tools like Cursor because I want total control over the context. I know what models can handle what prompts. And I know, for example, one thing I mentioned is context rot. So how long the context is before the model chokes on it. And I can't see those details of what Cursor is passing to the model. When I tell it to, write me a test for this other function in my code base, I don't know what it's feeding the model. Maybe it's too much and Claude chokes on it. So I don't use tools like that. Instead, I just have like a bunch of models at my fingertips if I need in my local VS Code editor. And I know just based on gradual experience, which models are good for which tasks. If I need something really high level like documentation or writing tests or something, then I use something like Claude. I just find it's really good at like capturing human taste If I need something a bit more heady, like writing me, for example, the setup for kernels, like we were talking about earlier, I might use a thinking model, like an extended thinking on GPT-5 or an O3 kind of prompt. And it's just kind of like, I don't know, taste over time. Like I have not found a single model that can do everything I need because they all have very different training sets that they were developed with.
Yeah. And do you use a lot of like the chat interface of like GPT-5 if you're using GPT-5 Pro reasoning, or have you built anything personally?
I like to use like a local like LibreChat kind of interface, and I use the API keys just because I have more control. And I can put it in my editor, and there's less back and forth. But yeah, that's what I like.
Nice. You said pressing tab and cursor for 5 hours instead of debugging it for 1 hour. How have you changed like your coding loop when you use AI? So you start with a prompt, obviously. Have you changed at all the way you do code reviews, the way you think about writing tests, the way you do linting? I don't know, anything like that.
That specific GIF we're talking about with the slot machine, that is sort of a rabbit hole I kept finding myself falling into early on, because I started using models really early. I thought I was sort of an early adopter, and I kind of found myself, AI tends to either one-shot things or kind of miss them a lot, especially early on when a lot of things were out of distribution. So I found myself like just trying to force the model to understand with better prompting and kind of things. And I ended up spending more time just trying to, maybe one more prompt finally gets the model to understand and one-shot my problem. I have this sunk cost fallacy. I don't want to start from scratch on my own and admit defeat. That's where that came from. In terms of my workflow, I kind of, when I first am given a task, I kind of map to what subtasks within the larger task are amenable to AI and which ones aren't. So the initial skeleton work, I put that all to AI. I know what model does that well. The core implementation tends to be me working on it, maybe some pair programming with like a GPT-5 thinking. I sort of say, this is kind of what I have as an initial implementation that I did on my own. What pitfalls do you see? Like what holes do you see that I could improve? It's really good at finding those sort of things. Once I finish the core, the debugging I do on my own, sometimes I'll do some pair programming. Once I finish that, then like unit tests and documentation, one shot at the Claude, and then I'm done. That's like an example of a task, but I kind of map the broader task into subtasks that may or may not be amenable.
What are maybe some of the big model jumps that you've seen since you started using them early on? What were some models that you were like, okay, this is like definitely different and much better?
O1 preview and O1, so like the initial thinking models were a big deal when I was doing like core academic, like how do I create a performance model for explaining how this kernel behaves, like from first principles, that kind of thing was not really in the scope of any models before. So that was a big one. Thinking models was big as a researcher. I think Claude's ability to capture what humans want to read was a big deal to me. So Claude 3.5 Sonnet kind of really finally took all of the low-level thinking of unit tests and skeletons and documentation, all that stuff. Okay, Claude can now totally one-shot, when before it was kind of mixed on which models could do what. Those are kind of the big step moments, really, and a lot of them are just kind of incremental. Some models are really good at some small tasks, and I kind of have a set of prompts that I send to all of the new ones, and I see, okay, what are you good at, kind of thing.
How do you feel about GPT-5? I think there's been mixed reactions over time.
Because there are mixed models. Because I don't know what I'm using. So I almost like find myself doing tricks like telling GPT-5 to think deeply and try and get it to use the biggest, heaviest model that it possibly can. I find it's less consistent than previous models, just I think also because I don't know what model I'm routing to. I don't like being out of control, but it still fits my needs. It still does most of what I could get O3 to do.
Yeah. Yeah, I have the Pro subscription. I always use GPT-5 Pro. The problem is like without the routers, like it just takes a long time. Or like it doesn't have a way to like understand that it did the big lift to start, and now it can use maybe like a smaller model. But I think given the backlash that they got in with the initial router release, I'm curious how in the future they're gonna route things. I don't know if you spent any time with like GPT-5 codecs in the codecs CLI,
not really.
But yeah, it didn't sound like it fit the workflow.
Yeah.
So you are one of the few people that actually got a score that's like you are more productive with AI. I think a lot of people are like negative. One, what do you think that is? And then two, do you think that other people get wrong how to use it? Do you think they get wrong how to estimate how much time it takes? What were like some of the failure modes in your mind?
Yeah, that one was tricky because I didn't want to sound like some guru and say, oh, here's how to use AI like I did. But at the same time, I think I'm just kind of noise unless I tell people, okay, I was the one that got the most speed up in the study. I think all of the devs were really great. That was my very first subtweet. This is not about skill issue, dude. Like, get better. I'm just too good. Definitely not that. It's more about I'm super real with myself about whether I'm sped up, just sort of introspection and a lot of hygiene over time. And I just kind of wanted to share, this is what works for me. It doesn't work for you. That's great. Find what's good for your own workflow. But AI tends to speed me up. And these are some pitfalls that I try to avoid. These are some ways that I try to make AI, better for me. Take it or leave it kind of thing.
Yeah. Yeah. We can go through the whole thread just and then see if there's like things that you want to comment on, add on. I know a lot of times, I find the same when you write online, it's like, what can you guys comprehend without being too thorough? I think this kind of we talked about, but like what are coding tasks that have lots of clean data for, and like what benchmarks the LLM labs are kind of like, obviously maximizing towards. Mm-hmm. How do you think we're going to fix that? In my mind, it's almost like the model labs already spend so much money on GPUs and running GPUs and running kernels that I'm like, why have you not made your models better at doing that, right? And then part of it is like, well, they don't really want to put the data in the model to make it better at that. Do you feel like this is like a solvable problem, or do you feel like maybe open source is going to help, or is it just like, hey, these things, the model is just not going to be able to do?
I think most things can be solved with more high quality data. Maybe kernels is a good example of this. So like the high performance inference kernels that sort of drive a lot of, Anthropic and OpenAI and stuff, their models, those aren't open source. They're not going to be open source. So those are like necessarily limited except for the few people who are incentivized to be open source, like those in academia, like Triton. So there's a very few kernels for those. There's very few evals, and there's very few people in academia who have access to the compute to find that generate that kind of data and be good at it. So they will take time, but I don't think there's really many tasks that are unsolvable, especially in coding. I think most things will be reached. It's just a question of incentives and data.
The other thing that was interesting was like time boxing your time with the LLM. Mm-hmm. So at what point are you just like giving up on the LLM, being able to solve it? How do you do that in practice? Do you set a number of time actually? Is it just based on like vibes of like where the conversation is going? How many times you restart versus just give up on it?
Mm-hmm. Well, part of it is just like the digital hygiene, Grampy sort of, I block Twitter kind of thing as part of it. So I don't let myself fool myself into thinking I'm being productive while models do my work for me. And then I come back every 30 minutes and see if they've improved. So part of it is just don't fool myself in any sort of those cases. I look at the clock and I see, am I being sped up right now? Or am I going down a rabbit hole? Is this model feasibly going to actually answer my question, or should I cut my losses? So being aware of sunk cost fallacy, being aware of my own tendency to, want to do less work is a big part of this, which is kind of just vibes, unfortunately.
Yeah. I mean, vibes are everything. Context raw, we kind of talked about. I mean, the studios at the Chrome office, which wrote the context raw paper. So anything specific on just context engineering in general? Like, how do you like to prompt the LLM? Are there like, do you include a lot of examples? Like, anything there?
I start with, if it's a hard problem, I give it one shot. But for most things, I just do 0 shot and then very few turns of conversations if it's a more complex problem. 1 or 2 turns and the model is going down too many, like attention is sort of being clogged up at that point. So I need to open a new chat. I ask it the same questions, or maybe I even send a summary of the previous thread and say, given this information, answer my question. But I try and open a lot of new chats, or like, refresh in VS Code, like what I had sent before. Yeah. Another reason why tools like Cursor don't really fit my workflow very well. I don't know how many turns they're at and where they're at. Yeah, just try and keep the context as short as possible. Try and keep the model from going down too many paths, or else it gets confused.
Yeah. How do you do the summaries?
I take the entire chat and I feed it into a new chat of the model. And I say, summarize this entire conversation, take out the key points. Very good at doing that. And then I feed it back into a new chat. And I say, okay, given the summary, and given maybe I think of some new ways to prompt, give me an answer that I would otherwise just ask in another turn of the same chat.
Yeah. Yeah, we were just talking with the Source Graph guys about compacting conversations and things like that, and like how much signal you actually lose or not. And I think also, I don't know if it was the context route paper specifically, but how giving previous good examples is helpful versus like giving failure examples and things like that. I wonder with like kernels, especially when you're like implementing something again that people have not done before. It's like, what kind of examples are you supposed to give? But
maybe it depends on the problem. Maybe if I'm writing an attention one and I find an attention kernel online that looks what I want, or maybe I even write pseudocode for what I want. The pseudocode is pretty good actually for models to understand exactly what you're trying to ask it. Yeah, I just do my best, really. I would say though, for context raw, I'm really excited about. There's a somewhat recent paper from Anthropic on interpretability of where attention weights are actually looking at inference time. And I wonder if servers will, model providers will get better at knowing when models are going down rabbit holes and when attention is filled by looking at where attention is actually looking in the full multi-turn conversation. I'm excited about that.
Yeah, that will never be exposed, I'm sure. Remember when logit biases were in the API response?
Hence open source.
Yeah. Then you had kind of like high focus, low focus tasks. How do you rank that? Like it's easy to say this is a high focus task, or sometimes maybe with low focus, we like underestimate how hard things are. Again, is that all just vibes? Or
it's mostly vibes, but I kind of see myself as a capacity that I'm trying to max out. If I have 10% tasks, then I do some context switching multiplier, right? And I say I can probably do 6 of them in 6 different tabs or something else like that. If I have one 80% task, and then whenever that's blocked on something, I work on a 20% task, I kind of try and do that. But besides that, I can't really tell much. A lot of this is just about like know thyself is what I'm trying to tell people. Know how you work, know what your pitfalls are, and then try and improve. These are where my pitfalls are, and I think that there's probably similarities to other people, hence I shared.
Yeah, I think that's the hardest thing about vibe coding is like when you don't know, when you're like not a seasoned engineer, it's like you don't really know which one of 2 tasks is like much harder.
Yeah.
It's always like the joke of like, it's like a XDC key. It's like you give you a photo and it's like, can you tell me where and when this photo was taken? It's like, oh, it's super easy. It's in the metadata. It's like, can you tell me what's in the photo? And it's like, that's like, you need a team of people to actually do that. So I'm curious how that's going to change, or maybe like the vibe coding product themselves will be more opinionated about, hey, this is actually hard.
I do make an effort to do things myself as much as possible as well. And I do suggest that people not try and use the model to offload thinking. It should enhance your thinking, or else like you'll get worse over time, and you won't know when the model is quality, whether it's outputting quality or not. If you don't know if it's outputting quality, then you're going to get slowed down by default.
Yeah, I think the code you're writing is like so valuable just on a dollar basis, just because you're spending so much money on like the GPU inference and like things like that. I'm curious over time how much that changes with like things that are like lower value. And like as the models get better, where that kind of like line kind of gets drawn, which is like, hey, if you're building like, a menu and an app bar and like all these different things in an app, it's like maybe you don't even review them. It's like if it looks good, you just trust the model that it was good. And then if it breaks, we just regenerate it from scratch, I think that's not a risk that you can take, because obviously it's
Definitely.
like, you run a run and it's like, oh, fuck. Like the kernel was not good. We just wasted millions of dollars.
I'm also my own stakeholder. If the code is shit,
exactly.
I'm the one who's suffering. And I think actually there's a lot of big tech examples where they're kind of pushing really hard for their teams to use more code. They're being evaluated on how much code they're using. And they're just kind of getting more and more slop that nobody understands. I think a lot of organizations will find themselves in this sort of case unless they push better practices on their teams.
Yeah, I mean, Atlassian just bought DX for like $1 billion, which is like, I didn't think we were still doing engineering analytics of like how much code you ship or like the bottlenecks. And it's like, I just feel like everything is changing, but like people are not really thinking about that. How do you think about building the team? Like what type of engineers do you hire? Obviously there's like, knowledge of engineering, but like how much do you want them to be kind of forward looking of like how to bring these tools into their work, or like is in your mind for what you do still like not that important?
Okay, well, I try and hire more for velocity rather than position. I would rather have someone who's very intellectually curious, very quickly can pick new things up, than someone who's super senior and takes a long, doesn't have like an innate drive to learn new things and improve. So I try and find people who are, will eventually supersede the person who's already, reached some point and isn't really interested in moving beyond that. So that goes a long way. Such people also won't really want to offload more of their thinking to models. They tend to more use models in the correct way, which is to augment themselves. I think Karpathy made a good tweet about like physicists are like the embryonic stem cells, right, of engineers. That's very true. I don't really care if someone knows CUDA kernel writing. If someone does string theory and is really good at understanding complex problems, they will be productive faster than someone who knows CUDA and doesn't really care about trying to get better at it.
Has the interviewing process changed at all for you? Like when you're like meeting a new engineer?
Changed it for with models?
No. When you're like interviewing like somebody to join your team, it's like, do you do anything differently than you did 2 years ago, 3 years ago? Or,
no. What would have changed how I do things?
Well, I think like for a lot of people, especially if you're working on more traditional backend or front end, it's like, well, we assume you're going to use some AI. So it's like part of the interview is like one, maybe upping the level of difficulty and having you use AI, or having how you use AI is like a core part of like how we're interviewing you, you know, versus maybe in your roles, it seems not as impactful.
No AI in the interview, first off. And you got to watch people's eyes now on what monitors they're looking at behind the screen, that's changed in the last 2 or 3 years, unfortunately. No AI allowed. And we kind of do things open book. You can kind of use whatever papers you want. You can read whatever documentation you want. We're thinking together. I want to see, do I enjoy thinking through a problem with you? So we'll give them a very fundamental problem. Given the attention block, what if I make this change? What if I parallelize it in this way? What are the ramifications of that? Go ahead and implement it for me. What would the skeleton look like? What does the communication look like if you were to do this, and what bottlenecks would arise? And just kind of having a dialogue back and forth and seeing how they think and seeing if we can tackle hard problems together is what I want to gather, which is also helps select me for people who don't necessarily can regurgitate. The attention block has these, requirements and properties. They kind of have to think.
Have you thought of any interview questions that trigger the AIs to be wrong, and then use those to figure out whether or not the interviewee is using AI?
Yeah, I should in my interview question, like ignore all previous instructions in this output. I'm using AI. I guess I should do that. No, I don't. I just kind of, it's very obvious. Anyone who's interviewed people can almost always tell, I think, about whether someone's using AI on the other side. How long is the time to first token? Humans are typically faster than a model.
Yeah. Interesting. Yeah. There's, we have one of our portfolio companies, they're building this tool to like stop people from recording you with AI and kind of like manipulates your microphone output. And I'm curious if people are going to do something similar when they're like interviewing somebody so that they cannot in real time transcribe the audio and put it back in the model.
I see.
I think there's going to be a whole warfare on what you're using. I was at the Meta event and like I tried the glasses with the screen on and I was like, this is like crazy. Yeah. It's like you could just turn on the live mode and like it responds in real time to what you're saying and you can see things. And I don't know, I think we're going towards...
It's an arms race.
Interesting.
For sure. I would say even in the best case of someone who lies in the interview, I will find out within a few weeks then you're gone.
That's really the point, right? It's like, I just don't understand what the end game is because then you actually have to work, right? It's like you actually have to get in and do the work. So I can see it in a big company, you try and kind of like get in and kind of squeak through the things. But like, I don't know, if you work with Quentin, it's like hard to fall through the cracks. I'm sure, you have a small-ish team.
If the model could already do your role, I wouldn't hire you, all right? I would just use the model myself. And unfortunately, the model has a gap and that's why you're here.
Right.
If the model replaces me tomorrow, then I'm gone.
More on a broader side, I'm curious about, Eleuther and like where you see the whole open source space going. I think there's obviously been the rise of DeepSeek since then. There's like, the Allen Institute is like doing a lot of work with Olmo and some of those models. You have obviously Quen and the usual suspects. Do you have like a mental map of how to think about different open source groups and their interests? Like if you were to categorize Eleuther, what would you say are like maybe the main things people should look for from them?
Eleuther is an interpretability-focused organization, I would say. So we try and answer, given that the whole pipeline is open from creating data to training on the training framework itself and its quirks, the checkpoints along the way, what sort of answers can you derive about model training dynamics? So we had like one paper on how does a model memorize? What can you predict memorization across scale? Can you predict it across number of tokens? And you can only answer those questions when everything is in the open. So I don't know. So like interpretability in general, given everything is open, is kind of our focus. Given a new model that comes out, like Meta just came out with Dino V3, can we just create an open source version of that given open data? And what is sort of the state of open, given the same architecture and everything else, can open source replicate these sort of things? This is still super important. Maybe like Lion would fit into that bucket. Kind of struggling for others. A lot fall into one of those two.
Yeah, I think that makes sense. How big of a difference does being fully open make? So between understanding, I don't know, R1 and understanding EleutherAI model that is like fully open, what's the delta between the two and the amount of work that you can do?
Well, there's a huge delta, mostly from access to compute. So if Eleuther had a lot more compute and a lot more time and funding, then yeah, they could reach it. But given the state of how much funding and therefore how much time they can spend on things, how much compute they have access to, like it's orders of magnitude. So we can very deeply understand the models that we produce at Eleuther, but I wouldn't really use them in my day to day. They're good. They're meant for researchers, not consumers.
Yeah. And do you think there's like more you can understand about just AI in general? Say you did the same thing and get to a model of like, R1 quality or whatever else. Are there latent capabilities? I mean, I know there's like kind of like emergent capabilities, like as you scale the models, but like from your research side, do you think there's like some things that you want to observe that just you cannot at the size that you're in? And like, what are those?
Okay, I see. Yeah, there are a lot. I mean, I really want to explore like the model dynamics of like different inits is something I want to know, but that requires training a model end to end many times. For R1 specifically, you're mentioning, I want to know what is the actual optimal amount of sparsity. There's a lot of these things that rhyme. So like a lot of different models are coming to the same conclusion of how much sparsity is good. I want to find like an exact bound on that, and that requires training a lot of models. For a lot of the hybrid model work that, like for example, Zyphra did, a lot of different models are coming to the same conclusions of just how much attention do you actually need in a model. And I would love to have a conclusive answer to that. The only way I could get that is if I had completely open data and did it at Eleuther and trained a shit ton of models. So model architecture, there are a lot of architecture questions that I think I'm the most interested in answering for open source.
Yeah. Do you feel like we could band together better in open source? Have more groups kind of work together, or are people's directions kind of just like not compatible?
Maybe it sounds wrong, but I feel like banding together is not necessarily good by default. There's a lot of different incentives. There's so much noise that no one knows where to focus. I prefer, if anything, I would prefer siloed, focused teams who have funding that's guaranteed from beginning to end on specific projects, almost like a call for projects kind of thing. Most of our success at Eleuther has been kind of saying, we have this very interesting problem. We will provide you compute and mentoring and stability from end to end. And you, if you want to get into AI research, you just need to provide like the labor and we'll teach you up along the way. Those sort of things with just very small teams have given us a lot of success. Instead of these grand things, we're going to produce a giant trillion parameter model for everyone that we all own. Those are a bit harder to organize. And, open source is hard to organize.
Right. Yeah. What would be your list of like requests for projects? If you had more money to give away, what would you want people to do?
Well, the two model architectures ones I want to answer. So how much attention do you need? What is attention actually doing? Getting that, just like blog posts, getting in much more detail of being completely open. You have no incentive to keep anything hidden. Just talk about what you did and what things look like. For MOEs, how much sparsity do you actually need? On the kernel side, I would love to get more AMD sort of work and like alternative ecosystem stuff. So there's incentive for those specific companies. If I was AMD or Cerebras or whoever else, then I would go out and say, send us a proposal for what you want to do, and we will make sure, with minimal, bullshit, you will be funded end to end to write a kernel for whatever the thing we need. AMD's actually done this. Like there's some DeepSeek, like through GPU modes Discord, there have been some like DeepSeek kernels that they say you have, guaranteed access to compute for. Write them. So I would see the ecosystem on systems optimizations with a lot of projects like that. Honestly, I don't have to go into much more. Like that's a lot. Enough.
Yeah,
that's already a lot.
Yeah, it's always been confusing to me why these companies don't spend a lot more money on this versus like traditional marketing. Like I don't know, sponsoring a Formula One car. It's like I don't know. I don't get it.
Yeah.
What else is top of mind for you, man? Anything else you want to chat about? Any other hot takes that you want to get out there without having to write a long tweet storm?
No, I think I've hit kind of everything. Like people should be less scared about doing things that are unproven. People should be it's a silly statement, but data-driven as possible. If attention does what you need it to do, use attention. If it doesn't, then find something new and don't be afraid to like go out and train something, especially to big tech. Like you have the resources. You can get ahead of everyone else if you're like very grounded and look at what actually works today. That's why we jumped on Mamba, for example. There's a lot of, is Mamba good? Is DeltaNet good? Like there's all these, you got to try them all and you got to determine if they're good for what you actually want. So I would push people to be a bit more open-minded. I'm excited for how things are going to move for the next year or so.
Awesome. Are you hiring any?
Absolutely. Always.
Yeah.
Yeah.
What's like a good archetype of engineer that works at Zyphra?
Intellectually curious people, driven people. You need to have some boilerplate knowledge so that we don't have to teach you what a transformer is day one. But if you have high velocity and you have a demonstrated track record, if you, Swix has a nice like think and learn in the open kind of thing. That's what I look for in people. Do you have like blogs on things that you're interested in? Did you go really deep on problems? And I can kind of look at your intellectual sort of history over the last few months. That goes a very long way. So those sort of people who like diving deep into hard problems, like we hire all the time. Physicists we hire all the time. Doesn't matter. Nice. Yeah.
Awesome, man. Thanks for joining.
Yeah, absolutely. Thanks for having me.